Welcome to Loksatta Yashasvi Bhava. Dear friends, last time in the previous session I have told you that trigonometrical sums of 10th standard could be classified into three main categories, that is terminal arms, initial arms, angle rotation. We have done those type of sums previously. Here in this session we'll be doing still a bit difficult part of the sums. Difficult because it requires a lot of practice and nothing more. Normally students find it difficult to prove the following trigonometrical equations. I have selected few which I would like to explain, but I have a request. Please do practice as much as possible from this part, because this normally comes for 3 or 4 marks here. Now let us see one sum of this type. Prove the following. I have mentioned it as type 2 as mentioned earlier. We have to prove square root of 1 minus cos A upon 1 plus cos A is equal to cosec A minus cot A. Now to prove this, what we have done, we have selected the left hand side. Left hand side is equal to square root of 1 minus cos A upon 1 plus cos A. That is equal to, we have rationalized here by using the conjugate, that is 1 minus cos A upon 1 minus cos A. Now here 1 minus cos A into 1 minus cos A is nothing but 1 minus cos A the whole square, the whole upon A plus B, A minus B formula we use it here. So we get 1 minus cos square A, that is the whole root. Whole root of 1 minus cos A the whole square upon 1 minus cos square A can be written as sin square A. We have used trigonometrical identity here. Now when we take the square root of this, we get 1 minus cos A upon sin A. Now here I would like to tell you that students normally don't extend this root, and let me tell you again, it's a mathematical error. Teacher will not give you marks for that. Further, now 1 minus cos A upon sin A, separate the denominator here, we get 1 upon sin A minus cos A upon sin A. 1 upon sin A, the reciprocal of sin, I already constantly been telling you, it's cosec A, and cos A upon sin A is cot A. Therefore we get cosec A minus cot A, that is equal to right hand side. Therefore we can prove left hand side is equal to right hand side, and in the end we can say square root of 1 minus cos A upon 1 plus cos A is equal to cosec A minus cot A. Now same type of one more sum I have selected for you. Please see the sum here. But there is a slight variation in the sum. I would surely like to tell you this, because this type of sum normally the idea doesn't strike during the examination time. So I want my students to understand this very nicely. Here we have proved that tan A upon sec A minus 1 is equal to tan A plus sec A plus 1 upon tan A plus sec A minus 1. Now we have selected the left hand side as usual. Left hand side is tan A upon sec A minus 1. We have multiplied it by the conjugate, that is sec A plus 1 upon sec A plus 1. So we get tan A into sec A plus 1 upon A minus B, A plus B. That gives you A square minus B square. Therefore tan A bracket sec A plus 1 upon, now here again we have used identities. Sec square A minus 1 up, that is nothing but tan square A. Now tan A gets cancelled, 1 tan A gets cancelled here, we get sec A plus 1 upon tan A. The story doesn't end here. What is more interesting here is sec A plus 1 upon tan A is not the answer that we want. If you see here, what we are doing, we have tried to find out, we compare this with what is given, that is tan A upon sec A minus 1 is equal to sec A plus 1 upon tan A. We take that value as k. Use theorem on equal ratio. When we use theorem on equal ratio, we get tan A plus sec A plus 1 upon sec A minus 1 plus tan A is equal to k. That's equation number 2. Here we have mentioned this equation as equation number 1. We compare both the equations to get the final answer. So in this type of sum, if you see, we have used theorem on equal ratio, whereas in the previous sum was any other method of prove the following. So this variation makes this sum bit different or difficult. The third type of sum that I have selected is from the prove the following itself, but still a slight variation. Here you have to eliminate theta if x is equal to a sec theta, comma, y is equal to b tan theta. What we do is we consider x equal to a sec theta. Therefore, sec theta is x upon a. Square both sides. We get sec square theta is equal to x square upon a square. Now we consider y is equal to b tan theta. Therefore, tan theta is y upon b. Square both sides. We get tan square theta is equal to y square upon b square. Now, by identity formula, 1 plus tan square theta is equal to sec square theta. Instead of tan square theta, we substitute y square upon b square, and instead of sec square theta, we substitute x square upon a square. That is how we eliminate theta from the equation. Mind you, what I have been constantly trying to tell you is, in all the three types of sums that you have seen, without using trigonometrical identity, none of them were possible. So please remember the trigonometrical identities very properly. That's what I would expect from all the students here. Dear friends, now for the third part or the third type of sums that we normally expect in the board exam is based on applications of trigonometry. Now, this type of sums normally are word problems, and it becomes important for the child to read the sum properly and understand what it means. Now here, but before that, we have got to know something else. Let's see here. Now, if the side or the line of horizon through which we see, and if we see up, then the angle of elevation. Now, for example, let me say it like this. My line of horizon is this. When I see up, my eyesight, it goes like this. So this becomes the angle of elevation. Same way, if my line of horizon is this, when I see down, this becomes the angle of depression. Same way here, when I repeat again, this is the line of horizon for this person. When you see up, this becomes the angle of elevation. Same way, when you see down, this becomes the angle of depression. Now, you first of all, when you read this type of sum, always see whether the sum is based on angle of elevation or angle of depression. Now, I have selected two sums for you. Let's see this, both the sums. One based on angle of elevation, other based on angle of depression. Let's understand this sum first. For a person standing at a distance of 80 meters from the church, the angle of elevation at its top is 45 degrees. Mind you, it is angle of elevation. Find the height of the church. Now, as I told you, whenever it is angle of elevation, that means the person is seeing above the line of horizon. Now, here, let AB represent the church. P is the person. Now, AB is the church here, P is the person here. Now, this person is looking upward, like this. He is looking at the top of the church. So, angle formed is angle 45. That means from the line of horizon to the angle of elevation, this angle is 45. Now, we consider AB to be x. Let height of the church be x. So, in right angle triangle ABP, we have tan 45, that is opposite upon adjacent, that is AB upon PB. Tan 45 is 1, AB is x, and PB is 80. Therefore, x is equal to 80 meter. That means the height of the church is 80 meter. This was the sum based on angle of elevation. Now we have the sum based on angle of depression. Let's see this. From the top of a lighthouse, an observer looks at the ship and finds the angle of depression to be 60 degrees. Mind you, it is angle of depression. He is looking at from the top of the lighthouse down. If the height of the lighthouse is 90 meter, then find how far the ship is from the lighthouse. Now here, let us say AB is the lighthouse, C is the ship, and the person is standing on the top of the lighthouse. That is, he is at position A. So AB represents the lighthouse, point A represents the observer, and angle DAC, this becomes the angle of depression. Why do I call it angle of depression? Because from his line of horizon, he is looking down. So when he looks down, this becomes the angle of depression. From the top of the tower, he is looking onto the ship. So he is looking down. So this is the angle of depression. So angle DAC is 60 degree. Now, by using your bit of geometry here, let us see alternate angles. Angle DAC is equal to angle ACB, both are 60 degree. Therefore, angle DAC is equal to angle ACB is equal to 60 degree. AB is 90 meter. Now, we want to know the distance of the lighthouse from the ship. So, let us say BC is equal to X meter. Now, tan angle ACB, tan of angle ACB is tan 60, that is equal to AB upon BC. Tan of angle ACB, how much is it? 60, tan 60 is root 3. AB is 90. BC is X. So we get X is equal to 90 upon root 3. We normally doesn't leave root 3 or any root in the denominator. It's a wrong idea of maths. So it is better to always rationalize. So rationalizing the denominator, we get 90 root 3 upon 3. That is equal to 30 into root 3. 30 into root 3, value of root 3 in the questions normally it is given as 1.73 or 1.732. So in case the value is not given, you can always keep it as 30 root 3. But still, if the value is given, it is not a good idea to keep it because the marks may be deducted for that. So I would request my students, if the value is given for root 3, please put the value that is 1.73 or 1.732, whatever the value is given in the question. Multiply it, the answer is 51.9. One request to all my dear students, please see to it that you keep the habit of writing the final answer. For example, X is equal to 51.9 is not the final answer. The final answer should be the distance of the ship from the lighthouse is 51.9 meter. That should be mentioned in the sentence because in the exams you may lose your half mark or 1 mark for the final answer. So remember that if there are 10 questions and even if you are losing half a mark, you are losing 5 marks for including algebra and geometry both. So please see to it that you keep the habit of writing the final answer. Apart from this, though I have shown you only 2 or 3 sums based on the limited amount of time that I had, I would request all of you to finally please go through some more sums or few more sums in the articles that will follow.